Welcome back, my probabilistically pure particles. I'm your quantum-entangled cook of consciousness, simultaneously synthesizing and observing science across all possible realities. You're tuned into a special bonus episode of the Multiverse Employee Handbook, where today we're asking the age-old question: what happens when a German physicist and a high school chemistry teacher walk into a bar? The bartender says, "Hey, I know you. You're Heisenberg." And both of them turn around and say, "You're goddamn right." December 5th, 1901 was a peculiar day in the multiverse. It gave us not one, but two reality-altering Walts. First, Werner Heisenberg, the physicist who would go on to prove that the universe runs on a very specific formula of uncertainty. And second, Walt Disney, who would prove that reality is whatever you can animate with a souped-up mouse and a dream. Now, I know what you're thinking, and so does the universe, but it can't know both that and where you're thinking it.
Wait, what?
You're wondering, what could a quantum physicist, a fictional meth kingpin, and a cartoon mogul possibly have in common? Well, my formula-following friends, they all understood one fundamental truth. Observation changes everything. Whether you're measuring an electron, cooking in an RV, or drawing a whistling steamboat captain, the act of watching something fundamentally changes its nature. Let's start with our original Walt, Werner Heisenberg, born in Würzburg, Germany, where he developed a formula for success that would make Walter White's 99.1% pure product look like a middle school baking soda volcano. Young Werner was the kind of student who made other child prodigies look like they were cooking with oregano instead of mathematics. By age 20, Heisenberg had mastered the kind of complex physics that would make even Gus Fring's best employees scratch their heads. He almost became a pianist instead of a physicist. Imagine a universe where the uncertainty principle is just about which keys you might miss during a concerto. Say my name. You're Beethoven? You're goddamn wrong. Like his future namesake in Albuquerque, Werner perfected his formula in basement laboratories across Germany. Though I should note that his pursuit of pure science was significantly less likely to explode than Walter White's. Usually. Both men understood that the perfect formula requires precise conditions, though one was trying to prove the impossibility of precise measurement, while the other was achieving 99.1% purity in a broken-down RV. Meanwhile, in a parallel universe of animation, Walt Disney was developing his own formula for changing reality, starting coincidentally with German fairy tales. Snow White's recipe for success required 7 key ingredients, all of them dwarves, none of them particularly useful in either quantum mechanics or crystal mathematics.
Jiminy crickets!
And speaking of uncertainty in German forests, Werner Heisenberg's early research frequently took him into the Bavarian woods, though presumably with fewer singing woodland creatures than his birthday twins' productions. Although, after enough time studying quantum mechanics, I suppose everything starts singing in superposition. Now, as we follow the formula into our next segment about the actual science, remember, in the multiverse of revolutionary Walts, every discovery exists in a superposition of states until observed. Werner Heisenberg discovered uncertainty, Walter White discovered certainty in chemistry, and Walt Disney discovered that if you draw it happy enough, it will whistle while it works. Stay tuned, my probability amplitude pioneers. Up next, we'll break down the actual formula that made Heisenberg's name synonymous with both quantum uncertainty and questionable RV activities. Now, my formula-following physicists, let's break down the actual mathematics behind Heisenberg's uncertainty principle. Don't worry. Unlike Walter White's recipe, this one's completely legal to share, though possibly harder to understand than Jesse Pinkman's approach to customer service. The formula, in its purest form, states that delta x times delta p is greater than or equal to h bar over 2, where delta x is the uncertainty in position, delta p is the uncertainty in momentum, and h bar is the reduced Planck constant. Or, as Jesse would put it, yeah, science, Mr. White! Let's break this down using something more relatable than subatomic particles, like your office stapler. According to Heisenberg's principle, you can either know exactly where your stapler is or how fast Carol from accounting is borrowing it, but never both simultaneously. The more precisely you measure one, the more uncertain the other becomes. It's like trying to track both your productivity and your Netflix watching during work from home. The act of measuring one inevitably disturbs the other. This isn't just some theoretical inconvenience. It's a fundamental property of the universe. Every measurement we make disturbs the system we're measuring. It's like when Hank from the DEA starts measuring the local methylamine supply. The very act of observation changes the behavior of what's being observed. Though I should note that Heisenberg's principle applies to particles, not drug empires. That's more of a Schrodinger's cat situation, where the empire is simultaneously legitimate and illegal until somebody checks the crawl space. The implications of this formula are staggering. It means that at the quantum level, nature itself has built-in fuzzy edges. There's no such thing as perfect certainty, which ironically is one of the few things we can be certain about. Walt Disney understood this too, in his own way. Have you ever noticed how animated characters move more smoothly than real ones? That's because they exist in a superposition of frames, each position uncertain until the animation is observed.
I'm Mickey Mouse. Toodles.
But here's where it gets really interesting. The uncertainty principle isn't about our inability to measure things precisely. It's about the fundamental impossibility of certain pairs of properties being precisely defined simultaneously. It's like trying to be both professional and comfortable in a Zoom meeting. The more you achieve one, the more the other slips away. And just as Walter White's formula had to be precisely 99.1% pure, Heisenberg's formula tells us why achieving 100% certainty is impossible. The universe itself enforces this limit, like a cosmic compliance officer, ensuring no one gets too precise about things. It's probably for the best. Imagine if we could know everything precisely. We'd lose all our best excuses for being late to meetings. Remember, in the quantum realm, as in the drug empire business, it's not about what you know. It's about what you can prove you know. And according to Werner Heisenberg's formula, there will always be some things you just can't prove completely, which coincidentally is also the first rule of both quantum mechanics and running a car wash business. Let's talk about legacy formulas. Werner Heisenberg's mathematics didn't just change physics. It fundamentally altered how we understand reality itself. Though I should note that unlike Walter White's formula, Heisenberg's actually became less dangerous once the government got involved. The uncertainty principle now influences everything from quantum computing to cryptography. Every time you make a secure online purchase, you're relying on the fact that some things can't be simultaneously known. It's like having a security system based entirely on nature's own don't ask, don't tell policy. Your credit card information is safe precisely because we can't measure everything perfectly. which is probably the only time in history that uncertainty has made bankers happy. Speaking of uncertainty in banking, both Heisenbergs left quite the financial legacy. One revolutionized our understanding of quantum mechanics, leading to technologies worth billions. The other, well, let's just say his formula for wealth accumulation was a bit more direct, though significantly less legal. Both, however, understood a fundamental truth. The act of observation changes the outcome, whether you're measuring electron momentum or checking your crawl space for cash. Meanwhile, in our third parallel Waltverse, Disney was proving that animation could transform entertainment through his own formula for success. Take something uncertain, like whether mice should talk. Make it certain, of course they should talk. And then add merchandising. It's the exact opposite of Heisenberg's principle. Disney made millions by making the impossible not just possible, but marketable. The irony isn't lost on our automated response system, which points out that in modern physics, we use computers that rely on Heisenberg's uncertainty principle to digitally render cartoons that Walt Disney would have once drawn by hand. It's like the multiverse has a sense of humor, or at least a deep appreciation for circular narratives. But perhaps the most profound legacy of all three Walts is this. They each showed us that reality isn't quite what it seems. Whether through quantum mechanics, crystal mathematics, or hand-drawn animation, they proved that observation and uncertainty are just different sides of the same coin. A coin that's simultaneously spinning and at rest until someone takes a look. Of course, only one of them got a theme park, though I'd pay good money to see Heisenberg's Uncertain Adventure or Mr. White's Wild Ride. Just imagine the gift shop possibilities. I survived the uncertainty principle and all I got was this T-shirt. Probably. Well, my formula following friends, we've reached the end of our quantum journey through the lives and legacies of three very different Walts. Today we've learned that whether you're measuring particles, cooking crystals, or drawing mice, the fundamental truth remains. Observation changes everything. Werner Heisenberg gave us the formula for uncertainty itself, proving that some things can't be simultaneously known, like where you put your keys and how fast they're disappearing into the quantum couch cushions of reality. Walter White showed us what happens when you pursue certainty with dangerous dedication. And Walt Disney? Well, he proved that with enough imagination, you can make even quantum physics marketable. Though I'm still waiting for that Heisenberg's uncertainty principle ride at Epcot. Remember, in the multiverses of revolutionary formulas, every discovery exists in a superposition of states until observed. The uncertainty principle teaches us that there are limits to what we can know, which, ironically, might be the most certain thing about reality. Though I should note that this principle applies only to quantum measurements, not to DEA investigations or theme park wait times. Our automated response system, which has been calculating the probability distributions of all possible endings for this episode, suggests that we're simultaneously finished and just getting started. But since we can't know both our episode's position and momentum, I suppose we'll have to collapse this wave function right here. This is your quantum coherent correspondent, signing off. Remember, in physics, as in cooking metaphors, it's all about following the formula. Unless you're measuring position and momentum, in which case, good luck with that.